Hello everyone, I am Ruchi Pathak, Assistant Professor from Department of Pharmaceutical Chemistry, LJ University. Today I am going to talk about Markovnikov's and anti-Markovnikov's rule, which is a part of electrophilic addition reaction of alkene. So let us start with Markovnikov's rule. It is nothing but addition of hydrogen halide to the alkene. To understand the Markovnikov's rule, we need to have some prerequisite. Number one is we need to have asymmetrical alkene as a starting material, and second thing is hydrogen halide, which is nothing but HX. Alright, so if we look at the definition, the rule states that the negative part of the polar reagent, which is nothing but hydrogen halide, is added to the carbon of the double bond which has minimum number of hydrogen. To understand this statement, let us look at this particular reaction. As you can see, this is one propene, which is nothing but asymmetrical alkene, and HCl over here is nothing but hydrogen halide HX. Over here, Cl minus will act as negative part of the polar reagent. Now, as per the statement, this chloride ion can be added to this part. We have to focus on this part. Okay, the carbons which are attached with the double bond. Alright, so the chloride will be added to the carbon which has minimum number of double bond. As for that, this carbon has only one hydrogen and another carbon attached to the double bond has two hydrogen. So as per definition, this chloride ion will be attached to this particular carbon and it will form this 2-chloropropane as a major product. Alright. If we need to have asymmetrical alkene for this particular reaction to occur, if the alkene is symmetric, say for example over here, at that time addition of any hydrogen halide will lead to formation of only one product, because the number of hydrogen attached to the double bond of the carbon will remain same, and that is why, as I said previously, the prerequisite of Markovnikov's rule is asymmetrical alkene. Let us move on to the anti-Markovnikov's rule, alright, which is nothing but exact opposite of what we have seen just now. Over here, the negative part of the polar reagent will be added to the double bond of the carbon which has higher number of hydrogen. As per that, this will be the major product as HBr, which is nothing but HX over here. The bromide ion will be added to this particular carbon which has two hydrogen as compared to the other carbon which has only one hydrogen. The main thing which we need to remember during this entire anti-Markovnikov addition is that peroxide, the presence of peroxide is mandatory. If the peroxide is not available in the reaction, then the reaction will be following the Markovnikov's addition. Now let us understand the mechanism behind anti-Markovnikov rule. Before that, we need to understand a specific terminology which is homolytic cleavage, which means, say for example over here I have written CH, which is bonded, the carbon and hydrogen over here bonded with each other via covalent bond. Now as we know, two electrons are responsible for formation of a single bond. So whenever we are breaking this particular bond, both the atoms will leave with one electron with itself. That is nothing but generation of free radical. This is homolytic cleavage, and this carbon radical and hydrogen radical is generated over here. This entire mechanism follows a free radical addition reaction. So to understand the anti-Markovnikov's rule, there are three steps. In the first step, this benzoyl peroxide is undergoing homolytic cleavage. As you can see, upon breakage of this particular bond, both the oxygen will leave with one electron. Now if you look very carefully, both of these parts are similar, and that is why 2 mole of this C6H5C double bond or radical will be formed. Further, this CO2 will be removed as gas, as you can see over here, and this free radical will be transferred to the carbon. Okay. HBr, that is your hydrogen halide. This HBr will undergo homolytic cleavage again, and there will be formation of bromide ion. As you can see, when this HBr, the bond is covalent bond is breaking, this hydrogen will have one radical which will combine with this particular radical, and there will be formation of stable C6H6, and this bromine ion, this bromine will be left with one particular radical which is generating a bromine radical. Coming to the next step, where this generated radical will react with your starting material, which is nothing but your asymmetrical alkene, and as you can see, there will be breakage of double bond, and this bromine ion will react with, or it will form a bond with, as you can see over here, the radical which is present on the carbon. So this is the first scenario which can happen, and in the second scenario, this bromine ion can attach to the carbon which has higher number of hydrogen. So there can be formation of primary radical, and there can be formation of secondary radical. Now if we look at the stability of the radical, it says tertiary, secondary and primary. That means tertiary is the most stable and primary is the least stable. So according to that, secondary radical becomes more stable, and that is why this will be the major intermediate during the third step, and this will further react with HBr. Again homolytic cleavage will take place, and there will be formation of this stable product. As you can see, this product follows anti-Markovnikov's rule. The reason being, the attached bromine or the negative part of the polar ion has been added to the carbon which has higher number of hydrogen, and the byproduct will be bromine radical, which will be further utilized in the reaction. So that is it for the mechanism part. One important thing which we need to understand is that this entire anti-Markovnikov's reaction will undergo only with HBr. If we look at all the HX, that means hydrogen halide, okay, this is the order of the bond strength of hydrogen halide, and the reason being, fluorine being the most electronegative atom, it will form a bond with hydrogen in such a way that hydrogen will not be able to leave easily. Alright, so homolytic cleavage in these two HX, hydrogen fluoride and hydrogen chloride, is not possible. But it is possible in case of HBr and HI. We have already seen that HBr can undergo the entire reaction, but the same reaction HI cannot undergo with. The reason being, if we generate the radicals of iodine, okay, because they are very unstable, it will readily form I2, which is a stable product. And that is why if the generated free radicals cannot undergo any catalytic reaction further, they cannot be part of entire mechanism, and hence this entire anti-Markovnikov's rule will be undergoing through only HBr as in halide. So that is it for all the reactions